So this video is about what to do with remainders. And so we're talking about division computations where there's something left over. So up to this point, we've really only been doing division where it goes in perfectly, goes in exactly, or we're estimating, and so it doesn't have to go in exactly. So this video is about what do we do when we do division, but then there's something left over at the end. So the big idea is that the remainder still needs to be divided. Now, this isn't a strict computational way. Okay. For example, there are times when it doesn't make sense to split the remainder. For example, if you have a bunch of tickets. So let's say you have 27 tickets and you're splitting them between 5 people. So that's 27 divided by 5. That's 5 per person with 2 left over. Well, you're not going to split up those 2. You're not going to rip those tickets into parts and pass them out. Right? So that's a situation where the 2 left over, it's just 2 left over. And so you have to decide what to do with that without splitting them evenly amongst the groups. So we're talking about contexts and situation where it makes sense to split up the remainder. So let's do sets. So how much of a group is left over is really the question that we're asking. So here's 27 divided by 5. So here's my 27 stars. I group them into groups of 5, and then if you notice down at the bottom here, I have these 2 hanging out. So I have 2 stars left over, and what then I want to think about is how much of a group is that? So I have 2 stars left when 5 would make another group. So I have 2, 5 would make a group, okay, a total of 5, 5. So that means I have 2/5 of a group. I have 2, 5 make a whole. So there's my 2/5. So 27 divided by 5 is 5 2/5. Okay, area. So 50 divided by 17. So I made a rectangle here that has 50 little squares. So each one of these smaller squares has an area of 1. And now I'm just going to start to find 17. So here's 17. Here's another 17, and then I don't have another 17. It turns out that I have 16 left over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Not enough for another group. So then the question is, how much of a group is that? Well, I have 16 when 17 make a group. So I have 16, 17 make a group. That means I have 16/17 of a group. So 50 divided by 17 is 1, 2, and then this is 16/17. There are 16 pieces that are still white. 17 would make a whole, so it's 16/17. So here I have repeated subtraction. So I have 249 divided by 122. So I subtracted 122, and then I subtracted 122, and then I had 4 left over at the end. So to figure out what I need to do with that remainder, so I have 4 left over, but 122 make a group, which tells me that 249 divided by 122 is 2, and then 4 122nds. So I subtracted 122, I subtracted 122, that's my whole number. It went in 2 times, and then I had 4 left over when 22 makes a new group. 22 makes a new group. Okay, so what about grouping? So now I have 483 divided by 4. I'm going to break this into 4 groups. So I started by passing out 100 to every group. So that means I passed out 400, so I'm left with 83. So I passed out 20 to every group, which means I passed out 80, which means I have 3 left over. So now I have 3 left. I have to figure out what I want to do with that. Now there are going to be 2 ways to approach this particular remainder. I can do a fractional remainder, or I can do a decimal remainder. So here we're doing a decimal remainder. So I'm going to take that 3 and I'm going to pass out 5/10 or half. So out of that 3, I passed out a half, a half, a half, a half, which means in total I passed out 2, right? A half plus a half is 1, a half plus a half is another 1, so I passed out 2. So now I have 1 left over. So I need to figure out how to split that up. Well, if I have 1 and I need to break it between 4 groups, I can pass out 25 hundredths to every group. Or if we think about this in terms of money, I have $1, I can give a quarter to every group. And so now what I did is I passed out a quarter, a quarter, a quarter, a quarter. So that was a total of 4 quarters, which is 1, which means I passed out everything. So now I don't have anything left. So then what's my answer? Answers with grouping, we look at how much is in every group. So group 1 has 100, 20, 0.5, and 0.25. So adding those together, that's 120 and 75 hundredths. And notice each group has exactly the same amount. Okay? That's a really important part of division, is that when you break these up into groups, every group is exactly the same size. Now, we could do this with a fractional remainder. So now I passed out the hundreds, I passed out the 20, and now I still have my 3 left over. So one way that I could think about this is I have 4 groups. Well, 4 groups, let's pass out quarters. So I'm going to give 1 quarter in fraction form to every group. And why would I pick quarters? 4 groups, 1, 2, 3, 4, a denominator of 4. So very nicely, when I pass out a fourth plus a fourth plus a fourth plus a fourth, that's 1. So that's one of the reasons we're going to often make that denominator match the number of groups. So now I passed out 1, so I have 2 left, so we're just going to, so I give a quarter to every group. That passed out another 1, so now I have 1 left over. So one last time, I give a quarter to every group. I passed out 1, now I have nothing left over, so I'm done. Every group is even, and I've passed out all of the 483. So then again, my answer is how much each group has. So if I look at this, I have 120 and 3/4. So 483 divided by 4 is 120 and 3/4, which is the same as 120 and 75 hundredths, or 120.75. Those are equivalent. One's just in decimal form and one is in fraction form. Okay, so what about long division? So whole number with long division. So here we started the long division. I took 453 and divided it by 12. So I did 12 into 45 went 3 times. So I subtracted the 36, which gave me 9. I brought down the 3. So then I did 12 into 93 goes in 7 times, which is 84. So I subtracted 84 and I had 9 left over. Well, 9 isn't big enough for 12 to go into. So now I need to figure out what to do with that remainder. So I have 2 options. So one, I can do a fractional remainder and I can just think, hey, I have 9 left over and 12 make a group. Well, that's what we were talking about with the area and the sets. So nothing new there. I have 9 left over and 12 make a group. So that tells me that the answer is 37. That was the whole number part. 37 and 9/12. So I had 9 pieces left over. 12 pieces would make a new group. So I have 9/12 of a group left. Or I can do a decimal remainder. To do a decimal remainder, what you're going to do is you're going to keep going. And what I mean by that is you're just going to keep doing long division. So you need to make sure that you put the decimal place where it needs to go. And then every digit after that is 0. Okay, so 453 is exactly the same as 453 and 0 tenths and 0 hundredths and 0 thousandths. So I can put any zeros I want. And now I'm just going to continue my long division. So I'm going to bring the 0 down. And so now I'm doing 12 into 90. It goes 7 times, but be very careful. Make sure that you keep that decimal point. Right, that's telling you the remainder part, that's less than 1 group. So that decimal point is going to tell you, hey, everything after this is less than 1 group. Then 7 times 12 is 84. I subtract it, that gives me 6. So I'm still not done. So I need another one. So I probably should write a 0 in here. And then I bring that down. And then 12 goes into 60 5 times. And then If I subtract 60, I have 0. So now I have nothing left. I'm done with my division. So the decimal remainder, 453 divided by 12 is 37 75/100ths, or 37 7/10 and 5/100ths, or 37.75. Your choice, unless a problem specifies, your choice whether you want to do a fractional remainder or a decimal remainder. Okay, so what about dividing decimals? So one method we used, or one model that we used for decimals, was area. So let's do this. So this is 8/10 divided by 34/100ths. So let's start by shading in the 8/10. So the two white columns over to the right, those aren't really a part of our problem. Okay, they're not included in this particular computation. I leave them there because it helps me remember how big all of those squares originally were. So now what I want to know is how many 34/100ths fit inside of this. Well, we like the 10 by 10 grid because each small box is a 100th. I just shade 34 of those, and then I shade 34 again, and then I have some left over. So the green is goes in one time. The purple tells me it goes in a second time. And then the gray in the middle here, those are my remainder. So it looks like I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 little boxes as my remainder. So 34/100 fits in 2 times with 12 boxes left over. So I have 12 boxes. 34 boxes would make a group. So this tells me that 8/10 divided by 34/100 is 2. It went in 2 full times. And then 12 34ths. 12 because I had 12 boxes left over. 34 because 34 boxes will make a group. Okay, decimals with repeated subtraction. So here's 12 2/10 divided by 2 3/10. So I did the subtraction for you, subtract, and then I was left over. I have 7/10 left at the end. So right now, I know just by looking at this work that I've subtracted it 1, 2, 3, 4, 5 times. So I know my answer is 5 and something, some part of a group. Not quite 6, didn't go in 6 times, but it went in 5 times. Okay, so we know it goes in 5 times with 7/10 left over, so we need to figure out what to do with that 7/10. So one way to think about this is to say that this is 7/10 when 2 3/10 makes a group. Okay, I know there are decimals in there, but it's exactly the same idea as what we've been talking about. So we have 7/10 left over when 2 3/10 makes a group. So that means that 12 2/10 divided by 2 3/10 is 5, and then 7/10 over 3 2/10. Now, mathematically, this is correct. This is a correct answer. Now, some of you are going to be a little bit uneasy and a little squeamish about the fact that we have decimals inside of fractions. That's totally fine. You're totally allowed to have decimals inside of fractions. Now, if you don't really like that, that makes you a little uncomfortable, right? Somewhere in your math career, someone has told you that that's an ugly number, don't deal with that. You're welcome to convert it. So if you don't like that, then using your idea of equivalent fractions, you can convert that. In this particular case, if you just multiply the top and the bottom by 10, then you're going to get 7/23. For me, either way is fine, unless the directions specify no decimals inside of fractions. Okay, decimal long division. So remember, you can't use long division if you're dividing by a number that's not a whole number. So what you have to do is you have to find equivalent fractions to get that denominator or the divisor to be a whole number. So what we did here, we rewrote the division as a great big fraction bar. So notice the numbers didn't change, I just rewrote it as a fraction. And then I multiplied the top and the bottom by 10 so that everything got shifted over. So the 2.5 became 25.2, and then on the denominator, the 2.5 became 25. So again, multiplying by 10 remember from your multiplication, just shifts it. So in this case, I only need one shift, and now I have a 25 in the denominator. So now I can use long division. So we set it up and it looks like this. I take 25 and 225 thousandths. 25 goes into 25 one time, so I put that underneath, I subtract, and there's my 0, and then I'm done. It only goes in one time, and then something left over. So this 0.225, that's my remainder. So what am I going to do with that? So if I want a fractional remainder, this is going to be exactly like what we were doing with the whole numbers. A fractional remainder, 225 thousandths, 25 make a group. So I know that my answer, 25 goes in one time completely, and then my remainder divided by my divisor. Okay. Again, if you're not really comfortable with having decimals inside of fractions, then you multiply by 10 as many times as you need to shift to get rid of those denominators. So in this case, we're going to multiply the top and the bottom by 1,000 because I need 3 shifts in the numerator. So 3 shifts is going to turn it into 1, and then 225 thousandths. Or if you want a decimal remainder, then just keep going. And that's the work here. So if you need to pause this and look over that work just to make sure you follow, go ahead. So 25 doesn't go into 2, so that's this first 0. 25 doesn't go into 22, that's this next 0. 25 does go into 225, and in this case it goes in exactly 9 times. So then we're done. Right? So important things to note here, make sure that your decimal point is lined up, and then make sure that you have zeros where zeros are needed. So going back to the original problem, 2.5225 divided by 2.5 is 1 9 thousandths. Okay, so what about fractions? No surprise here, we're going to do area. So 4 4/5 divided by 1 2/15. So I drew 4 4/5. Now, I just want to make it clear what's happening in this last box. So down here, I have a red sort of cross over that last box. Do you know why? Because I want 4 4/5. So here is 1, 2, 3, 4. My last box needs to get broken into 5 parts, but I only want 4 of those 5 parts to be 4 4/5. And I always keep that last box, or the boxes that aren't being used, because it helps me remember how big the pieces are. If I just have 4 written out, I might think, oh, those are fourths. Or if I know there's something missing, how am I going to remember whether it's fifths or sixths or sevenths or eighths? Also, if I do need to change the denominator, change the size of the pieces, leaving that sort of unused piece on the side can be very, very helpful. So that's why that last piece has a red mark through it. So let's figure out how many 1 2/15 fit inside of this 4 4/5. So I chose to do it this way. So I chose to take that last box and break it up into 15ths. Okay. And then I did my colors. So I took 1 yellow, that's 1 whole, and then this became 1/15, 2/15. And then I moved to my blue. Here's 1 1/15, 2/15. Then the purple, here's 1 1/15, 2/15. And then the green, 1 1/15, 2/15. So right now, looking at my picture, I know that it goes in 4 times with something left over. So we need to figure out a way to describe this remainder part. So 4 pieces completely, and then, so 4 pieces left over. So that's that's the 4 pieces. 1, 2, 3, 4 pieces left over. And now the question is, and it's not as obvious in this, is how many of those pieces would make a group? In other words, how many of these smaller rectangles would it take to make one group? All of the yellow, or all the blue, or all the purple, or all the green. So to do that, I'm just going to break them up into that size piece. So I chose to do the purple, but you could do any color you want. So notice I took this hole, this purple box, and I broke it into 15ths because this box is broken into 15ths. So now I can see that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 17 of those small boxes, or 17 15ths, make a group. Not getting somewhere. So now my remainder was 4 pieces. 17 pieces make a group. There we go. My remainder is 4 17ths. So 4 4/5 divided by 1 2/15 is 3 4 17ths. Okay, so we're going to try another one just for practice. 5 5/6 divided by 2 1/4. So 1, 2, 3, 4, 5. This last box was broken into 6 parts, and we're taking 5 of those. So again, that last box is going to be broken off, not included. So now I'm going to fit 2 1/4 inside of this. So here's my 2, 1, 2, but I don't have fourths. So I'm going to break that third box into fourths. Fourths didn't look obvious to me in this box here, like it did on the last question. So I'm just going to go ahead and break this one into fourths. That's fine. Let's find another 2 1/4. So the turquoise, there's 2 1/4. And then I don't have enough left over to get another 2 1/4. So the rest of the white boxes, that's my remainder. Well, this one is definitely more challenging than the last one because these 2 boxes that are white definitely are a different size than these boxes that are white. So I'm going to have to try to describe those remainders. And I'm going to do that by breaking them into the same size pieces. Hopefully there's no surprise there. So notice I had 6 broken up in the horizontal direction. I had 4 fourths broken up in the vertical direction, so I just carried it over. So if I have 4 here, I'm going to have 4 here. If I had 6 broken up here, then I'm going to make it 6 broken up there. And then very quickly, they're the same size piece, and now I can count. So now I can see that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. I have 32 boxes left. That's my remainder. But how many boxes make a group? So that's the next part. So 32 boxes left over, but I need to figure out how many make a group. So I'm going to break up, I chose orange this time, I'm going to break it up into the exact same breakdown as I had in this over here. Okay, so I made it 4, 6, 4, 6. And now I can count all the boxes that make up the orange. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54. So 54 of those small boxes makes a group. If that's the case, then I know that 5 5/6 divided by 2 1/4 is 2. That's the orange and the turquoise. That's the 2. Then I had 32 boxes in my remainder. 54 boxes make a group. So 32 54ths. Summary. Whatever is left over still has to be divided. So ask, how much of a group is the remainder? In fraction form, the amount in the remainder over the amount in one group.